Hey guys, welcome back to the shop. It is hot today. Now if you're in your shop or in your driveway or garage, wherever you're at, and you're working on your car, the heat sucks. It really does. But what sucks worse is if you're driving your car and it's hot and then your car overheats. So in this video, we're going to talk about keeping your hot rod or your Chevy Nova cool. Alright, so if you're going to try to keep your Chevy Nova or whatever hot rod you have cool, there's a few things you have to keep in mind. You know, how much horsepower are you making? Horsepower is heat. Now, about 100 horsepower is 250,000 BTUs, roughly. So if you've got a 300 horsepower engine, you're going to make about 750,000 BTUs of heat. Well, a third of that's turned into mechanical energy, another third of it goes out the exhaust, and the last third of it has to be taken care of by the cooling system. Alright, so if you have a stock car with a stock engine and a stock cooling system, you probably don't have any issues as long as everything is in good condition. But if you've upgraded your engine, making a little more power, you're making a little more heat, and you're going to have to make sure everything else is up to snuff. The factory radiators in these cars, most old cars, were copper and brass. Brass tanks, steel end plates, and copper fin tubes in the inside. Most of them came with base engines, V8s or 6-cylinders, and they had a 2-core radiator. Well, a 2-core means it's got 2 tubes that go across. A 4-core radiator or 3-core was used in some heavy-duty applications, and it was better and provided more surface area than cooling. But that's not enough. Sometimes when you have a high horsepower engine, you need even more cooling than a factory 4-core can offer. Now, a lot of people just assume that they need a 4-core radiator when they have a hot rod that's making any kind of power. And you know what? If you're talking about factory stuff, yeah, the 4-core is better than the 2-core or 3-core. 3-core is better. You know, the more cores, the better to a point. Because what happens is, as you have your cores in a row, and the water is flowing from one side to the other, unless it's a divided radiator, which most factory ones were not. It's flowing across, and as it's flowing across, you have each tube. The hotter one's in the front, the airflow comes across. Well, then the next 3, the more tubes you have, the last tube's going to be hotter because it's collecting the heat coming off of the first 3 tubes. So if you've got a 4-core radiator, your first 3 tubes are all getting cooler air than the last tube. So the more tubes you add, actually the more transfer heat you're getting from the first 3 tubes, and it's less efficient. So a 3-core may be more efficient than a 4-core radiator and may actually cool better because your last core isn't really losing any heat. It's picking up heat from the first 3 cores, or at least not losing as much heat as the first 3 cores are with the airflow going by. Now, for the last couple of decades or more, aluminum radiators has been where it's at, and there's a reason for that. Copper is a better conductor of heat than aluminum. So if you had a piece of copper and a piece of aluminum and you wanted them to cool down, the copper would cool down faster than the aluminum mostly. Now, even though copper is, I think, a pretty good bit, probably close to double as efficient at transferring thermal energy than aluminum is, copper is also heavier and more dense, so it also will retain heat better than aluminum, which is a paradox probably. But anyway, copper brass radiators are not all copper. They're copper, they're brass, and they're all put together with lead. And lead is a terrible conductor of heat. So you have an aluminum radiator like this, and it's all aluminum. Well, that's a better conductor. It's lighter than copper, and it's a better conductor as far as a whole unit, it's a better conductor. Now, copper may be a better conductor as a material, but as a whole unit, an all aluminum radiator is a better conductor than a copper brass radiator with leaded joints. Alright, so far we've decided that an aluminum radiator, because of its construction of all aluminum, is a better heat dissipator than a copper brass radiator with leaded joints. Alright, now copper does, like I said, transmit heat better, but aluminum radiators transmit heat better than copper radiators. As a material, copper's better. As a radiator, aluminum's better. It's all aluminum instead of 3 different metals. And don't even get me talking about dissimilar metal corrosion when you start introducing 3 different metals together, or 4. Now, a copper radiator, like I said, usually comes in 2, 3, or 4-core. Well, here's a factory 2-core that I cut a little section out of. You can see how small the tubes are in the cores. Well, and then you see the fin pack and all that stuff. Well, then you've got lead at each joint, so ton of resistance for heat when you encounter the brass and then your copper and all that stuff. So pretty thin. Well, this radiator is also a 2-core, and it's almost twice as thick as far as the center section of it. And the reason that is because these have 2 1-inch cores in them, plus it's aluminum. So you've got a bigger surface area in your cores than you do in this one. They're both 2-core. This one's got 2 1-inch cores, so you got 1 inch on top, of each core and 1 inch on bottom. That's 4 inches total of heat dissipation. Well, this one's got a 1/2 inch. So you've got 1 inch on top and 1 inch on bottom. That's a total of 2 inches. Well, this one's twice as big as that one, and they're both 2 cores. So the amount of cores really doesn't matter. It's really the construction of the radiator and the efficiency of the radiator. All right, so now you've improved your radiator efficiency. You went from a copper brass 2-core or 4-core to an aluminum 2-core, and you've got more heat dissipation with this radiator than you do with the stock one. All right, you've done good. Now what about airflow? Well, airflow is probably the biggest cause of overheating. It's not too small of a radiator. You ever watch Roadkill, some of these other shows? What do they do when the car starts overheating? Well, they don't go find a bigger radiator. They take the hood off. Why? Airflow. Airflow is 80% of the reason most cars overheat, unless the radiator stopped up or low on fluid. Now, of course, that happens. But if you put a new radiator in and the cooling system's new, and you're not getting your temperature down where it needs to be, it's probably an airflow problem, like 80% of the time. That's why taking the hood off makes such a big difference. You're getting more air in and more air out. Now, sometimes you can be getting enough air in and the engine bay can't dissipate it, but that's a car problem, not a radiator or cooling problem. So you have to deal with that somehow. All right, so you have 2 ways you're going to get air through your radiator. The first one is easy. You're driving down the road, air is going to push through the radiator. The second one is your fan, whether it's mechanical or electrical. Now, all the old cars had mechanical fans on them. Some of them were just straight drive fans, flex fans. Some of them had clutch fans on them. I like clutch fans. You know, they move a little bit more air at low RPM and slip at high RPM because you're probably going down the road at a higher RPM and you don't need the fan. It frees up a little bit of horsepower. Now, if you go with an electric fan, it puts a little bit of horsepower loss, parasitic loss through the alternator, having to keep up with the charging or the electrical system, but it really doesn't have any parasitic loss on the engine to speak of. So that's a lot better deal. But it takes a heck of an electric fan to move enough air once you start making some horsepower. Also, a lot of electric fans are mounted straight to the radiator. You really need a shroud. Whether it's a mechanical fan or an electric fan, you have to have a shroud to make sure that your fan is pulling all of the air through the radiator it can, not just a section of the radiator. The radiator can't work as efficient as it's designed to unless air is passing through all of it. Now, if you're driving down the road, air is probably passing through all of it. But if you're sitting still, which is where you're most likely to overheat, slow traffic, parking lines, stuff like that, that's where you really need the most airflow through the radiator as possible. Now, if you have a shroud and it goes to the edge of the radiator, you also need to make sure that your fan is, for the most part, as close to the radiator as it can be, because the fan can suck air beside the fan into the shroud and back out the thing if the fan shroud isn't sized correctly to the fan blade size, or if the fan shroud isn't far enough, the fan isn't far enough into the shroud. Both of those can cause the fan to recirculate its own air and lose efficiency. Okay, so what have we learned so far? Aluminum radiators are better than copper brass radiators, period. That's a fact. Now, also, 2 large tubes is better than 4 small tubes if the 2 large tubes are more surface area. And also, you don't get as much transfer heat from the first to the second tube if you only have 2 as you do with 4. So it's a lot better design, it's a lot more efficient. We also learned that you have to get enough air through your radiator. Now, whether it's a mechanical fan or electric fan, you need a good shroud, you need as much air as possible, and you really want the fan to be mounted efficiently as far as the size of the shroud around the fan, and then also the distance between the fan and the radiator. And a lot of these, you don't have much choice. The fan's going to be real close to the radiator, especially if you've stuffed a big block in it or something like that. So now you've got your aluminum radiator, you've got your fan shroud, you're moving plenty of air through there. Hopefully you won't have to take the hood off. Now, the other thing you have to consider is your water pump. Now, a mechanical water pump has a pump curve. All pumps have some type of pump curve, and they're efficient up to a certain RPM, or the efficiency has a range where it's good at. Generally, a automotive water pump, the more RPM you spin it at, the more fluid it's going to move. Well, that's not always the case, and up to a point. If you start moving real high RPM, which is not that typical, not at sustained, unless you've got like a 456 gear and you're driving down the highway at 4,000 RPM. But for the most part, you're going to cruise at a lower RPM. You're going to be getting plenty of air through the radiator, and you're not going to have too much of a problem with overheating. But if your water pump at low RPM, idling, like I said, stuck in traffic or in a line somewhere, drive through, whatever it may be, if your water pump is moving at a low speed, it's going to move the coolant at a low speed, and it will dissipate more heat the longer it spins in the radiator. But at the same time, you got to get cool water back to the radiator fast enough to absorb the heat being built by the engine. Now the good thing is at low speed you're making low horsepower. So cruising down the road you're making maybe 50, 60, 70 horsepower. You're not really under load until you put it under a wide open throttle or something like that. And at idle you're making way less horsepower. So that's way less heat, but you're also moving less water. Now some people go to an electric water pump. You have to spend a pretty good bit of money to get a good electric water pump, so to keep up with street driving. But the good thing about electric water pumps is they stay at a constant speed unless you've got something that's speed controlled. They stay at a constant speed, whereas a mechanical water pump speeds up and slows down with the engine. So I've put my car in neutral before and revved the engine up to 1800 RPM trying to cool the engine down, and it works for a minute, but it also makes more heat as you raise it up, so it kind of defeats the purpose. Okay, so you want an aluminum radiator, not a copper brass, unless you're just trying to be original. Well, you want a 2-tube radiator. 2 large tubes is better than 4 small tubes. That's a fact. Now, also, you want to move as much air through the radiator as you can, which means you're going to need a shroud that's big enough to get both sides of all the way from side to side of the radiator, and you're going to want your fan placed properly in that shroud to move the maximum amount of air. Whether you use an electric fan or some type of belt-driven fan, you want to move as much air as possible. Now, you also want to consider your water pump. Like I said, pumps, electric pump runs at a constant speed. A mechanical pump runs, at a low speed at idle and a higher speed at RPM, where it's more efficient, where it also needs less, cooling because you've got maximum airflow. So an electric pump can help your cooling out if you buy a good one. But a cheap electric pump, you're probably going to burn it up and overheat, or it's just not going to move enough fluid. And speaking of fluid, you want a good fluid. Water cools better than antifreeze, period. Now, antifreeze has a higher boiling point, so a mixture of water and antifreeze is pretty good. It keeps your car from freezing in the winter. It keeps your car from boiling over, but it does lower your heat dissipation. So you can use something, if you're not worried about freeze protection, you can use something, a wetting agent. Water wetter is the only one I can think of as brand name at the moment. But you can use some type of wetting agent that also raises the boiling point of water slightly. It lowers the surface tension of the water, which increases heat dissipation, and it adds as a lubricant and corrosion protectant like antifreeze does for your water pump and for the inside of your engine. And all that's pretty important. But you want the most efficiency you can out of your cooling system. You're going to need a good radiator, good water pump, a good shroud, good airflow, and you're going to need a good fluid to do that in. So make sure everything's clean. Now, if you have a factory system, you can run some of these flush stuff through there, but if you run some of that through there and it, all of a sudden causes leaks, it's because you already had the leaks and the corrosion was stopping up the leak. So be wary of some of that stuff. If it'll flush debris and deposits out of your radiator, it'll also flush debris and deposits out of the holes that you don't know you have in your radiator. Okay, so I hope this helps. Good radiator, good fans, all that good stuff, good coolant. Enjoy your hot rod, but keep it cool, because overheating an engine and ruining it is not cool, not at all. See you guys next time.